Integrals and absolute values. How we handle those is one way to do it. If I do the integral, number one, integral from negative 5 to 2 of the absolute value of x dx. Any thoughts on how to do it? Yeah, actually we did do this one with the triangles. We just interpreted in terms of area, but other than that, how can we do this kind of more of a direct sort of way? Well, this is where we're going to use, we talked about one of the properties is we can break it up. If we're going from A to B, we can break it up from A to C and then C to B. That's what we're going to do here because, remember we can break up the absolute value of x into pieces. We've done that several times now. We can say it's x or minus x depending on where we are. It's just x if x is bigger than 0, right? Greater than or equal to 0. And if it's less than 0, then we plug in minus x. So that's what we're going to do here. Same sort of thing. Because, this absolute value of x, the v shape, well, true enough, it's the absolute value of x overall. But on this side, what we're saying, on this side we can say it's minus x, and on this side it's just positive x. See what we're saying? Huh? Yes. It will all be positive. Yes. But to do the integral, we don't know how to do the antiderivative of the absolute value. So we have to break it up into the pieces, one piece or the other. That's what we're going to do. And the breakdown here is at 0. So what I'm going to do is break my limits up. Instead of going from negative 5 to 2 straight through, I'm going to start here at negative 5 and go to 0 for one part, and then 0 to 2 for the other part. You see what I'm saying? So I'm going to break these limits up. I'm going to go negative 5 to 0 for the first part, integral. Then I'm going to do a second integral, 0 to 2. Won't that cover the whole span? Yeah, that's one of the properties we talked about last time. We can break it down like that. Okay, so if I do that, what goes here and here? Well, that's where these come in. I'm breaking down the absolute value into either negative x or positive x. Which one do I put here? That would be the negative x. Yeah, I'm on this side of 0, so that would be the negative x. And then this is just x, yeah. So that's one way we can get around that absolute value. See, we took the absolute value out by getting rid of it. One side's the minus, the other side's the plus, if you will. Okay, well, of course, the antiderivative here will be negative 1/2 x squared, evaluated from negative 5 to 0. This one will be 1/2 x squared from 0 to 2. So that would be easy for this one, right? Negative 1/2 would be 0 squared minus negative 1/2 negative 5 squared, which is 25. Go ahead and do that. Of course, that's 0. Then this one would be 1/2 of 2 squared, which is 4, minus 1/2 of 0 squared, which is 0. So that's 0. So this is good. Minus, so it's a positive 25 halves. Plus, that'd be 2. 12.5 plus 2, 14.5. If there's a hole, can you do it? No, the reason we can do this here is we're still continuous. A hole, remember, that would be discontinuous. And this doesn't apply if it's discontinuous. This is not discontinuous. So there's a difference, yeah. That is a good point. This is still continuous because I'm not breaking. It's a corner, so it's not differentiable, but that doesn't matter here. As long as it's continuous, you can do that. But if there's a hole or an asymptote, yeah, that's different. Okay. All right. So what if I'd had, is everybody okay on that one? What if I had the integral of negative 6 to 5, absolute value of x minus 3 dx? Do I still break it up at 0? No, I break it up at the corner, right? Where there's a corner. And if you look at the absolute value of x minus 3, the corner happens where? Positive 3. So I'm going to break this one up into two parts, but the dividing point, if you will, dividing value is 3, which is in that range. So I want to go the first integral, what? Negative 6 to 3, and then the second one, go the rest of the way, 3 to 5. Okay? First integral, negative 6 to 3. Second one, 3 to 5. And add those two together. All right, well, the deal is one of them's a negative, the other one's just the positive, right? Which one is it? Well, if it's not, this one just shifts it over, so it's nothing different. This would be the negative side of it. This would be the positive side, if you will, of the absolute value. I'll talk more about that in just a second. So what would this be as far as goes here? Negative x minus 3 dx. And this would just be x minus 3 straight up dx. Now, of course, here it's going to change the sign, so it would be negative x plus 3 dx. So that would be what? Negative 1/2 x squared plus 3x, negative 6 to 3. Oh, so that's nice. Okay. This one would be 1/2 x squared minus 3x from 3 to 5. Plug those in, and you got it. That's negative 1/2 times 9 plus 9 minus negative 1/2 be times 36. 3 times 6 is minus 18. Over here then we'd have 1/2 times 25 minus 15 minus 1/2 of 9 minus 9. So do all that out. See, we have minus 9/2 real quick, plus 9 plus 18. Oh, that works. Oh, it's minus 18 again. All right, plus another 18 plus 25 over 2, not 52 over 2, 25 over 2 minus 15. Then that'll be minus 9/2 plus 9. I get 42.5. Sound about right? Now, quick point before we do one other one here with the absolute value. If I compare, this is y equals absolute value of x minus 3. If I compare that to the graph where it's just x minus 3, no absolute values, what happens is these look similar. Well, they look exactly alike until you get here, but this is just a straight line, so that just keeps on going down there, right? So what I want you to see is what the absolute value did to this graph was it flipped this part up. In other words, this negative part got flipped up. Keep that in mind. Okay? That'll help us on this next one. All right, so what if I had integral negative 1 to 3 of 4 minus x squared dx? Another absolute value. This one, though, is not just a V shape. Notice this graph 4 minus x squared, the absolute value, I believe it looks like this. Can I have a W? Yes. Something like that. Where this is negative 2 and that's positive 2. Make sure that's right. I think that's right. Is that right? Okay. Okay. So now I'm going from negative 1 to 3. Well, I missed this corner, but I have this corner right here. So I'm still going to have to break it up. So where's the breakup? At 2. Yeah. So I'm going to break this integral up, negative 1 to 2, and then I'm going to go 2 to 3. Is everybody okay on that? Make sense? Negative 1 to 2 and then 2 to 3. But which one is which? I mean, so far we just said this side was the negative side, this side was the positive. May not be the case. And that's why I told you about this. If you just look, this is the absolute value, 4 minus x squared. If I just look at 4 minus x squared, think about that. Isn't that this? Which piece got flipped over? Yeah, this piece did. That's the part that got negated. And then this piece, this one doesn't come into play, but this piece got negated. So this is the negative side of the absolute value. This is the positive. This would be another negative side if we had to. You see what I'm saying? So what goes here? Is that the negative side? That's the positive side, yeah. This is just 4 minus x squared dx. This is minus 4 minus x squared because it's the piece, if you will, that got flipped over. That got the minus treatment. Okay, so what do we got? 4x minus 1/3 x cubed, negative 1 to 2. This would be minus 4x plus x squared, so that would be minus 4x plus 1/3 x cubed from 2 to 3. So that would be 8 minus 8/3, doing this quick, negative 4, negative 1, so it would be positive 1/3. Then over here I have minus 12 plus 27 over 3 is 9. Minus, plug in 2 would be negative 8 plus 8/3. So if we get all that, let's see. 6 minus 16/3. Okay, we got plus 4 minus 1/3 minus 12 plus 9. I got 11 1/3.